statement. 1, 2, 3, 4. How many disagree? Okay, so I get everybody is abstained, right? Because I'm going to say something stupid. No, you're not going to say something stupid because it's not that SIP is badly engineered. It was not designed for this day and age. When you think about it for a minute, first draft was 1996. Hello, 2018, we're 22 years later. If you take the original draft and you take the current renditions of the RFC and the various iterations of it, it didn't change that much. Basics are basics, primitives are primitives. The overall concept is identical. So what happened? Well, in 22 years, we all became bunk. Somebody beat us on the head and we stopped doing our job. And the thing is, if you look at SIP as a standard, it's very much academic. So most of the work had been done inside various committees, inside various academic bodies that were completely disconnected from the real world, like most things in academia. Reasonable. So you don't care about the world. NAT is not an issue. Media will stream properly in an ideal world. And then we get things like stun and turn and ice and all kinds of things that God knows why we really need them. So a few years later, we got this group of wonderful people that live on the internet. They're called Google and all kinds of other companies, and they come up with a new standard and say WebRTC. It was promoted by the forces of the web, so we wanted communications inside a web browser. Okay, it was designed for web browsers, and yet it was never designed for small devices. And it's still reliant on the same technology that has caveats, such as RTP and SRTP. So we're still bound to those NAT issues, those network environments that are excruciatingly difficult. Now, I'm referring right now to specifically voice and video. I'm not talking about data channels. Data channels, awesome thing, but I'm putting that aside. Now, the worst thing that came to us with this is that where previously voice over IP and telephony and telecommunications were governed by people who did this as their day job. This is what we do. We look at packets. I have programmers in my company that I had to teach how to work and how to look at Wireshark. Normally when somebody tells me there's a problem, my first response is, where's the PCAP file? Don't talk to me without a PCAP file. Anything else is just pointless. And so we end up with this. So one of the things that Einstein is attributed to is saying the definition of insanity is doing the same thing over and over again and expecting different results. So we have SIP, and we have WebRTC, and effectively we have the same thing. Personally, I don't see much of a difference between them. It's a signaling here, a signaling there, media here, media there, same problems. So we're doing the same thing over and over again. What, have we not learned anything? So we must be insane in some form. And so it means for us inside the company, we said, when we started designing Cloudonics and what we want to do, we said, something is wrong with this architecture. Something is wrong with how things are being done inside because we keep on doing the same old things. And, well, you know, so let's reinvent it. Let's invent something completely new. So we sat down for about 2.5 weeks, bashing each other's head, thinking of a new way of doing signaling and media and blah, 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 reached a very simple conclusion. Can somebody translate this, please? It's too fun. It's a lot of fun, yes. You're correct. It's so much fun. Okay? So how many of you have got kids? Oh, a good number. Awesome. Tell me something. Here's an interesting question. When you look at kids learn something new, what do they do? Wait. What was the first one? They repeat. What do they repeat? Come up here. What do they repeat?
Me.
What?
Me, parent.
They repeat you. Oh, that's one. But what else? They experiment. They are willing to take a chance, which is something that most of us are not willing to do because we're too bound by our constraints. We are bound by our methodologies. We're bound by the way we were taught of how SIP and VoIP and RTP and SRTP and blah, 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 how these things work. And we're also bound by the business models that all of these give us. And we said, no. It just doesn't make any sense. We have to think of something completely new here. So we set out on an adventure. And we said to ourselves, okay, we want to re-engineer SIP. So it will fit a low-scale, small battery-consuming device. And we wanted to be also, from an app point of view, we wanted it to be able to run on a device that has only one core. Not dual core, not quad core, one core. How many devices do you know today that has one core? Each one of you has it. All of you have it. What? No, that's not one core. That's too many cores. You're overheating anyway. So how many of you got a car? Who has a car? Who has a car entertainment system? That has one core. It's barely an ARM. It's barely an ARM 5. It's so freaking slow and small, it's unbelievable. And yet, it's an entertainment system. We wanted to rethink how media is handled, and is RTP and SRTP really the answer? We hadn't gotten to that point yet. So, bigger question. And we wanted to use as many parts of what we currently have, but in a different way. We said, all these tools are out there. We just need to mash them up differently than what we've been taught to do. Because if we change the way we thought, and we change the way we look forward, we'll have progress. We'll invent something new. So we set ourselves a few goals. Number one, no more registration. The concept of registering a UA to a SIP proxy or a SIP server or anything is pointless. It's not only pointless, it's battery consuming, it is annoying, it is excruciatingly to debug, and it's a lot of noise on your network. How many of you maintain a network of 10,000 registered devices? 100,000? 1 million? 50 million? Nobody. Okay, different question. How many servers will I need to maintain 50 million, so let's not take 50 million, 5 million registered devices? How many servers do I need?
What's the registration interval?
Way too many.
Normal. 60 seconds. Oh shit, what's the options? Oh shit! That's a big beep network, right? So how many servers? 60, 70, 100? 24 servers. Okay, we maintain 5 million users on our networks, actually 6, using 6 virtual machines on DigitalOcean. And that is just a proof of concept. Okay, so how do we do that? Anybody can give me an idea? No registrations. Oh, great! So how do you do no registration? There's the ball. Here's the racket. Come on. So I'm going to get to that in a second. Number 2, no more hardware. If you're thinking in bare metal concepts, stop. Containers, virtual machines, Kubernetes, orchestration, whatever you want to do. Forget about those bare metal machines. They're pointless. We've gotten to the point where virtual machines are almost as strong as bare metal. Okay, and you can build enormous clusters of virtualization environments that cost nothing. Literally, I bought 2 servers last week with 256 gigabytes of RAM for about 500 pounds each. It's nothing. Question, what is the most agile cloud right now if you want to do pure cloud automation? If you want to control your entire stack completely automatically, which one is the preferred one? What is your favorite? Amazon. Why? Who said that? You're not getting another one. Oh, okay. So he says Amazon. I think he's right. What?
He had kids, right? Need many.
I have kids?
No, he had kids.
Oh, he has kids. Yes, probably.
He needs many batteries.
Yeah. So right now, as far as we can see it, is that Amazon is the right tool if you want to do true cloud automation, simply because it gives you the right amount of tools and the right concept of how to use them. Yes, they're complex, and then yes, in some form they're annoying, but it gets the job done. So, as I said, scale, and when you think about scale, is we need to stop thinking of scale as telecom. We need to start thinking scale as web. Because when you think about a telecom company, you think 10 million users is a big number, huge number for a telecom company. 10 million extensions. How many of you have got 10 million extensions on their network? Not even one hand comes up. No, you got 10 million DID numbers. Don't do that. I know who you are. And you got 10 million extensions? How many servers does that need?
Sorry?
How many servers does that need? How many servers?
It keeps changing.
Keeps changing. Okay, so what happens if you want to do 100 million users on that network? How long will you work?
I think we're going to scale easily up to 50 million, but not 100 million.
Not the 100 million.
Yeah, a new data set.
Exactly. So here's the thing. In order to scale from 10 million to 100 million, it should be just one thing to do, a click of a button, and not even that. That is web scalability. If you look at companies like Taboola, for example, who do content recommendation and video analysis, these guys are scalable to trillions of clicks per day. Terabytes of data traversing the network all day long. And they're able to scale up in seconds. How did they do that? What, because it's web? It's because the architecture is different. And here's one thing that Ule is going to love, and some of you are going to say, no, we hate you, is that one codec to rule them all. For voice, it's Opus. Guys, if you're not using Opus, then you're doing something fucking wrong. And yes, I've said an obscene word. Okay, I don't care. I'm Israeli. I'm allowed to. I'm politically incorrect. And we won the Eurovision, and I'm in Germany, so I don't care. And if it's for video, H.264. Now, I know that some of you will say VP8, VP9, blah, blah, blah. At the end of the day, H.264 gives far better performance on one hand, and you have open source libraries that Cisco made out. So, yeah, why not? So, what did we do? How do we get to the point, how did Cloudonics come to the point that we're able to do all of that? And we've done it in about 2.5 years. It's been 2.5 years worth of development, almost 7 engineers working on it. So we started with registration-free dialing. I said, don't do registration, don't register. Can somebody give me an idea how to not do registrations inside a SIP platform? Use a TCP connection, such as? Oh, you're saying, okay, let's establish a WebSocket or something like that, or maintain. No. That's costly and will kill your phone. Thank you very much. I don't want, if you ever do that on my phone, your app will get thrown out. Number 2, yes?
Client certificates.
Client certificate. That's an interesting concept, but what will you do with it? You will submit it? What are you going to do with the client certificate? A blockchain. Oh my God. No, just don't say that word. Please, no blockchain around here. Yeah, in the green. Yeah, you. Oh, it's black, sorry.
For mobile devices, you could do push notification, so you would never register the device, but in the case there's an incoming call, you would always send a push notification.
Very good. That is the way to do it. What does that mean? It means that your mobile device...
It doesn't use any battery
exactly. That's
until you get a call.
bullseye. If your mobile device stays offline at any given second, at every given minute, you will never consume battery. So your phone needs to wake up only when it needs to wake up. And thankfully enough, both Apple and Google now have what's called VoIP push, or invisible push. So it's a push notification that comes to your phone and able to wake up an application without waking up the entire phone. So that's number one. Number two is that stop using passwords. That's number two. So we had to develop a completely new mechanism of how to do authorization and authentication on the platform. So we incorporated tokens, single time, per call, per session, per dialogue tokens that are generated on the fly. And then we said to ourselves, you know something, that's pretty cool, but that's not enough. Because then we created something crazier, which is an authorization API. So technically, the platform allows you to go about and say, I'm going to authorize against somebody else. We can actually give your domain authorization outbound of the platform to do it completely externally. So you can write your own. You want to do something normal registration? That's possible as well, because we support normal UAs as well. Geographic media positioning. What does that mean? Anybody has an idea?
So you select the media server that's closest to the user. So if the user is UK, you don't need the media server for US.
That is very close. That is very close. Actually, media positioning in our case means that we have a whole worldwide network of media processors. These are not media servers. They're basically media relays. And they will actually traverse IPv4 to IPv6 according to the requirements of your mobile device. So it's more than just media. Because media on its own is beyond media. It's both media, your transport, your network layer, your latencies. Do you have an MPLS network running from inside China to Hong Kong to bypass the great firewall of China and then dump it into Amazon? You can do that. But in order to do that, you need your network to be designed and your mobile device to communicate with the network in order to do that correctly. Device profile fragmentation. This is one of the biggest challenges of any mobile app vendor. And that is, how do I support the number of mobile devices out there? How many mobile devices out there in the world? And I say models that are called Android. The closest answer gets the last of these. And I'll tell you this, it's more than 1,000. What? 2,500, more. 10,000. One more number, come on. 7,000. Wow, you're all off completely. No, that's completely off. So the closest one is the guy in the back, so you'll have to come and get this afterwards. The actual number from last week is 19,843 device models. Each one has 4 different media paths, 2 methodologies for every type of audio processing, and with the software option, 3 different algorithms and 3 different libraries of how to do that correctly. To put that into your software to support any type of device is virtually impossible. It's just too much. So what we created is what we call the Fragment Engine. The Fragment Engine enables us to create profiles for devices on the fly and push them into the devices automatically without needing to do any updates. And on-the-fly provisioning. Now, if you want to be able to scale up really well, on-the-fly provisioning means that Us, as a cloud platform, we don't want to know anything about your users. Nothing. We don't want to know who they are, where they are, what type of device. Well, we do want to know what device they are because we do the Fragment Engine, but we don't care about anything other than that. More than that, you don't even need to tell us who they are. Because everything is token-based and we can completely externalize your authorization mechanism, we don't need to know who they are at all. The result is that your overall footprint, because you don't have registration, because you don't have anything to do with actual passwords, and all those keep alive messages that run all the time, the overall footprint lowers down. So this is what we did. I'm confident that you have your own thoughts. And number one, I would love to hear your questions on one hand. And if you want to continue discussing this afterwards, I'll be happy to. Questions? Boom. No questions.
Here we have Tim, of course. It's
Oh,
warming
Tim is
up.
going to grill me.
Hi, Tim Panton. So you didn't mention encryption of the media. Do you do encryption of the media?
We do by
How do you generate the keys?
Well, the keys are auto-generated. So every client that we push out on the SDK by default has its own X509 certificate depending on its own domain. And that is customer oriented. In that case, that every customer has their own X509 certificate per domain. The default on the platform is SRTP, DTLS SRTP by default. TLS is the default signaling path. We do support UDP and TCP as well, but we don't like it. So it's just for compatibility reasons.
Tori. And then Marcin here with probably the last question, because then you can grab Nir outside. It's here, prepared.
You talked about making your own authorization API. How does your API compare and differ from, say, a classic OAuth flow?
It's very similar in general. The concepts are, I would say, fairly identical. The main difference is that the API authorization gateway enables you to do not only OAuth. So if you would like, somebody would say, I want to be able something to do with OpenID, or something that is connected to your Active Directory, you can do that because effectively it's just a REST API.
Hi.
Wow.
I have a
Thank
question.
you.
How do you?
I'm blind.
About your geo media servers. How do you find the closest one to the user? Because probably they use RTP engine.
We do use RTP engine as part of our stack. That is true. What we normally do is that when the SDK pops up for the first time on the device, or when the application launches, it has several points it will actually check before the application launched, traverse it back to our system, and we'll basically hand it over the right service to use. It's completely dynamic.
Okay, thank you, Nir. And for more questions,